Hello, and thank you for joining us for Introduction to Ductless Heat Pumps, Part D, Installing Systems. This is the fourth module out of four. Previously, other modules released were making the business case for ductless heat pumps, sales techniques for ductless heat pumps, design and sizing considerations, and now finally installing systems. Feel free to continue on with this module, regardless if you've seen the others, but you'll probably want to make sure you get all four if you're looking to make ductless heat pumps a part of your business. As with all four modules, the images used here were either given direct consent to be used or were taken from places where usage rights have already been granted. We want to talk a little bit about who NEA is. The Northwest Ductless Heat Pump Project is an initiative run by NEA, and NEA is a nonprofit organization with members from across the Northwest, primarily your utilities. Also, however, Bonneville Power Administration, Energy Trust of Oregon, and some other energy efficiency organizations are also members. What makes NEA unique is NEA leverages investment from all the utilities in the region to actually help buy down costs, to help provide education, marketing assistance, and in general make sure that each utility that participates in a program has the best opportunity to leverage each other in making sure a market is actually transformed. So in this case, NEA, the Northwest Energy Efficiency Alliance, has put together the Northwest Ductless Heat Pump Project, and this is one of our efforts to make sure we get this early education out there to help contractors who are deciding whether or not to add ductless heat pumps into their business have a better grasp of what it is they're getting themselves into. What we hope you'll get from this module. Well, there's a lot here, but really the key we want to focus on is improving the installation quality. Now, this does not replace full training that you might get from a manufacturer or distributor or from a certification course that you may take on HVAC, air conditioning, or heat pumps. This is really designed to give you the overview and help you understand what is involved in ductless heat pumps as a business. And hopefully this will give you the motivation to take another step, get that right training, and get hands-on experience to move forward. The outline for today, we're going to cover some of the basics. Some of this will be review if you've sat through some of the other modules. If you have not yet, this will hopefully catch you up. Then we're going to talk about line sets. Line sets are the refrigerant lines that run from the outdoor compressor to the indoor head, and we're going to talk about them. We'll talk about those outdoor units or compressors as well as the indoor heads. Then we'll talk a little bit about some of the common mistakes we find in projects, and we'll wind up with resources at the end, things that you can use to help move you forward in your journey to adopting ductless heat pumps. We'll start with the basics. So along this, we've come up with this path to ductless contracting success, and it's a four-step process. The four modules that we've developed don't line up exactly with these four steps, but each one of them is a critical component to helping make sure you get through these four steps. So we've already covered the basic awareness, sales and marketing, and we've talked a little bit about firsthand experience. This is really going to think about installation training and the skills and value proposition along the bottom of the path. And the hope here is, again, you get this experience, you get this training, and this pushes you forward to move down the road of contracting success. So let's keep going with the basics. A DHP system, or a ductless heat pump system, also referred to as a mini split heat pump. And the reason why it's a mini split is if you notice the size of the compressor, the outdoor unit here, it's about a third to a quarter of the size of an old compressor for a standard air conditioner or a central heat pump. Hence the term mini split. With mini split or ductless heat pump systems, there are four critical components. The outdoor unit, also called the compressor, is where we're able to take heat from the outdoors, even in cold temperatures. And through the process of refrigeration, compression, and expansion, we're able to actually take heat from the outdoors, even down to very low temperatures, move it through the refrigerant lines to the indoor head, where an air movement, a fan coil, moves air over these refrigerant lines and extracts that heat back out. And the process works the same in reverse through cooling. So that's the outdoor unit. The refrigerant lines connect them, and then the indoor head has a high efficiency fan that's actually able to modulate its speed according to the needs of the house. This is all managed by the controller, sometimes referred to as the wand, the one that's pictured here. Now, the wand is kind of a glorified remote control that's really designed to control your ductless heat pump. For those of you, or for some of your customers who prefer the wall-mounted thermostat that they're used to for their other heating systems, most manufacturers do make a wall-mounted controller as well, and so that is an option, and we'll talk a little bit about that a little later. We also want to remind you that the Northwest Ductless Heat Pump Project is really looking at ways to get into the market at the lowest cost for consumers, so we can hopefully see adoption move pretty quickly. When we think about that, we look at places where electric resistance heat is the heating source for the home. That is our #1 priority. And instead of trying to replace the entire system, which can be done, absolutely, we're looking to use a process we call displacement. So we look at the pre-existing condition here, where there's baseboards in all the rooms, or they might be wall heaters, and they're used to heat each room individually. What if we could displace the use of the baseboards in the main body of the home, where people spend the majority of their time? If we do that, it's called a displacement approach. And this way we can typically put in a single head, indoor head, and a single compressor outdoors, get air conditioning and get this nice heat pump heating into the home at the lowest cost to the consumer, while still reducing their energy bills anywhere from 30 to 50%, depending on the size of the home and its design. So with displacement, we put that single head DHP in the main living area, and it's going to do the bulk of the job for the parts of the home that people spend the majority of their time. Now, you still want to use your baseboards or your wall heaters in the bedrooms particularly, and you may want to turn those down a few degrees, 2 or 3 degrees. And it turns out most homeowners are okay with their bedroom being just a couple degrees cooler than the main body of the house. So with this approach, the ductless heat pump does the lion's share of the work for heating and cooling of the home, and you still have these baseboards or cadet wall heaters for those instances where you still need some additional heat throughout the house. In doing this, we provide summer air conditioning to the home. It's about half the heating cost of heating with electric resistance heat. And again, we're not actually telling you to take out the baseboards. Those can actually remain and provide that backup heating throughout the house. There are other options. If you have a centrally heated system in the home, you could do something in a replacement system, something like putting in a multi-head mini split system. So this is 1 or more compressors outdoors and several different heads indoors. This would allow you to provide heat pump heating and cooling throughout the home, or you could do a centrally ducted heat pump. So it replaces sort of like a furnace, and they actually have mini split versions of these, and they'll do a fine job. We want to really tell you, though, this is a much more complex strategy than displacement, and that's really not what we're hoping to cover today. So if this is something you're interested in, you're going to want to get further training down this road, but we do want to admit that this is absolutely a possibility, and this is something that for some homes is really necessary to do. But again, we're not really going to cover this much more than just letting you know that this is an option for homes that really need it. Now, there are some required tools for doing these installations, and if you're already doing HVAC in homes, you probably have most of these tools already. If not, you're going to want to purchase each of these. And even if you have some of these tools, we may ask you to purchase a separate set just for these DHPs. And I'll explain as we go through why that is. The first, you want an R410A ratchet flaring tool. And the reason why is that the flares that come factory designed from the factory, from the manufacturer, are really designed just to keep the thing together as it's being shipped. They're really not ideal for the rigor that will be necessary once these systems are fully charged. So you're going to want to create a new flare so you have excellent connections. You're also going to want to make sure that your R10A flaring tool and your gauge and hose set are specific for R410A. So if you're working on other systems with other refrigerants, go ahead and keep that equipment and use it for other systems, but you really want one designed for R410A for a couple of reasons. One, you want the thing that is the tools that are most appropriate for the product you're going to be using, but also the oils that are used to make some of these connections can be different for different refrigerants, and we don't want any cross-contamination. You will want a programmable refrigerant charging scale, and we'll talk a lot more about this in a bit. It's often not necessary for a displacement installation. It really depends on the manufacturer and brand that you're using and whether or not you have to add additional line set beyond, say, 25 feet. But having this tool is going to be really critical for those times where you do need to weigh in some more refrigerant. And finally, a torque wrench. We know a lot of contractors say, my elbow is calibrated. I know how to tighten this just right. And while that may be true in some cases, the joke is that, a 6-year-old child with a torque wrench is going to more accurately get your flare nuts tightened than would a seasoned professional with a monkey wrench. So really, it's a good idea to have a torque wrench so you don't over or under tighten any of your flares. Let's take a visual tour so you can get an idea of what some of these pieces look like and get a little bit better visual into this process. And then we'll go a little bit more into each of these parts and what's involved. So this is an indoor head mounting template and bracket. This is going to be really important. And if you've ever had to, say, hang a TV, a flat screen TV, it's a similar type process. We want to make sure that this bracket is properly secured to the wall. So it's mounted onto the studs, and this will give the strength to hang the ductless heat pump indoor head onto the bracket. And here we have someone actually mounting a ductless heat pump head. The indoor head mounts and secures directly to that bracket. What you're not seeing here is, some holes had to be drilled in the building beforehand, and the electrical and the refrigerant run through, but this is what it looks like mounting that indoor head. This is the line set, or that refrigerant tubing, and it's already got insulation with it. This is how it typically is shipped, and so we want to make sure that when we install this line set, or these refrigerant lines, that we really do have quality insulation covering it all the way from the compressor to the indoor head. This will ensure that we actually get the heat to transfer where we want it to go, and it will prevent condensation on these lines, which can always be a challenge. Running that line set is going to come with some things you really do need to be thinking about. What is the pathway you're going to use to get from that indoor head to the outdoor compressor? In other words, are you going to have to go through an attic or a crawl space, or can you go directly through the wall as we've seen here? You want to understand the distance to that compressor. Most of these pieces of equipment come with about a 25-foot line set maximum before you have to start weighing in refrigerant. And you can quote me on that to a degree, but please read your manufacturer's specifications. Each manufacturer will be a little different on the appropriate line set before you need to weigh it in. So that distance is important. If you can get within 25 feet, that's going to be really great. And of course, you need to think about the obstructions that might be in the way. Is there a doghouse there? Are people storing things on the exterior of the building? Is there a lot of shrubbery and bushes? Those things can all make an installation much more challenging and can make any type of work later much more challenging as well. So these are all three things that you really want to be considering when thinking about running that line set. There are two different ways you can mount a device. You can either mount it on the ground or on the wall. And in scenarios where you have a lot of snow, snow drifts or high regular amounts of snow, mounting it on the wall can be a really nice option. This can also be for those instances where you need to mount it much higher, say for a second floor. So if you have a split home and you need to mount it higher, these wall mounts can work quite well. Similar concept to that indoor bracket, but much more rugged and sturdy because it has to hold this heavier compressor on the outside. If you're installing one on the ground, you're going to need to have one of these pads, and it can be a concrete pad, or they sell specific plastic pads just for this purpose. And we'll talk a little bit more about setting this, but you'll want a pad, you'll want some risers. You see a couple different versions of those in the lower right-hand corner, and those are enough to give you some clearance off the ground. So whether it's leaves or debris, running water, or even a little bit of snow, you've got that clearance underneath your compressor. Connecting the line set. This is where that torque wrench is going to come in handy, and you're going to connect it at both the compressor on the exterior and on the indoor head. One of the challenges here is getting that insulation just right. And we'll talk a little bit more, but the insulation around these line sets, try not to cut it off too much It's better to scrunch it back when you make your connection so that it flexes and covers this entire line. Weighing in refrigerant. So I talked a little bit about this. You will need to have an EPA 608 refrigerant license in order to be able to handle refrigerant. And the EPA a couple of years ago passed new rules that have to do with handling and recording refrigerant that's weighed in and waste refrigerant after any job. So you're going to need to have that certification. You're going to want to have your programmable scale and your gauge and hose set in order to do this. Again, as I stated, for a lot of devices, if you're able to put them within 25 feet of line set run, you may not have to weigh in any refrigerant. But what we find is most contractors, while that's their first goal, will inevitably find some scenarios where they really do need to run it longer. So it is a good idea to get that refrigerant handling license and to make sure you have the right equipment to do this work. There is going to be some connecting of electrical and for both power and communication so that the wand inside actually controls and sends messages to the outdoor unit and the indoor unit. So you're going to need to be thinking about this, and this may require that you either subcontract an electrician or you have an electrician on staff to be able to handle this work. And of course, follow all proper codes and laws when handling any electrical equipment. The condensate line. As a part of the way these systems operate, condensation is created in the indoor head, and that condensation needs to go somewhere. So it's recommended that you bring that condensate line to the exterior of the building. One of the tricks you see on the right-hand side of the screen is this clever installer actually ran the line set condensate line, sorry, not the line set, the condensate line directly to a downspout. So this has a way for that condensate to actually move itself away from the building and not create any wet spots either on the siding or at the base of the building. Controls and homeowner training are also going to be critical. I mentioned the wand is the standard, but they do have these wall-mounted systems, and each of the major brands do have their own wall-mounted temperature controls that allow you to treat it much more like a standard thermostat, but a wand will work terrific, and it's not necessary that you move to this. It's just good that you know that it exists. So when you have this conversation with consumers, you have a good idea of how you want to do these controls. Many of these brands also are starting to develop apps that can be used much like a smart thermostat. You can log in, you can check the runtime of your unit, you can adjust the temperature remotely, and it actually will work as a kind of a backup wand or backup controller. So look to that if this is something you think your consumers might be interested in. Talk to the manufacturers and distributors and pick products that actually include these types of apps or smart controllers. And finally, really the number one thing that we find in quality control problems is improper homeowner education and improper homeowner expectations. So you really do want to go through the process of training the homeowner both how to operate their system, what to expect from their system, and the basic maintenance that comes along with these systems. Some of the maintenance items associated are cleaning the filter on the indoor head and checking that condensate line at least annually to make sure there's no blockages. The Northwest Ductless Heat Pump Project does provide a lot of collateral, and we'll show you in the resources at the end, the website, and you can go and you can download these, and they can be really nice pieces for you to use when you have the conversation with the homeowner, but you can also use collateral that has been developed directly from the manufacturer you're working with. The line sets themselves, or the refrigerant lines. So connecting line sets. Remember I mentioned don't use the factory tubing flares and the factory fittings. They're really not designed for the pressures and the rigor that is necessary for an operating system. They're really there for shipping. So you want to create new flares using that R410A flaring tool that I mentioned. You would apply refrigerant oil to the end of each flare. And remember, this is one of the reasons why we want you to have specific equipment just for working for R410A. And then you want to connect the tubing on the indoor and outdoor units with nuts. Now, these are supplied usually with the equipment, but it's not the one that is shipped with it. If you look at the picture, that beefier of the two nuts that says has DHP with an arrow to it, that is the nut that we really recommend that you use. And then you use a torque wrench to tighten to the manufacturer's specifications. Refrigerant charge. Only do this if it's actually necessary. Many or most installations don't actually require adjustments because they come pre-charged. When they're pre-charged, you don't really need gauges to verify the refrigerant levels because, again, they're factory set to work this way. But consult your manufacturer's installation manual and verify that the protocols we're talking about today apply to the equipment that you're installing. And again, make sure you do have your refrigerant handling license if you're going to be doing this work. There are a variety of different fitting types in the market. Some of them are used creating flares. And that's going to be pretty common, particularly as you connect to the outdoor unit and the indoor unit. But what about if you ever need to do additional connections? Here are some examples of some fittings that aren't full flares. The press fitting and the compression fitting. These are specialty equipment that you usually have to get separate. But what we find is these have lower leakage risks than a standard flare. Standard flare fitting really does take a lot of experience and a little bit of luck and proper application of oil and proper torque to get these really well. Whereas the compression and the press fittings are a little bit more simple and easier to master. Again, you do have to purchase them separately, but they can really elevate your game in terms of reducing the chances of having refrigerant leakage. We do also want to make sure that this line set is fully insulated, as I mentioned. And it's not just that it's insulated. We also want to make sure it's got UV protection on it. And there's a couple different ways. You can buy line set that comes with UV protection. You can put a UV protection tape over the insulation, or you can put a line hide, which we'll show in a few minutes, which really gives the ultimate in protection and really improves the looks. We also like to mention here, we want to make sure that you have a weatherproof wall penetration. So since you're going to have to run that line set and the electrical through that exterior wall, you're going to want to make sure you get it really weather tight. We don't want to get water or insects or air moving in and out of the walls due to this installation. Next, let's talk a little bit about the compressors themselves. So here's your typical outdoor compressor, also known as the outdoor unit. And some of the things we're pointing out here, the wall penetrations have been sealed with an insulative sealant. Again, it's really going to fill all the gaps and make sure that you're not going to get air, moisture, or insects coming in. You'll see the rigid line hide. It looks almost like a downspout there. It's usually a plastic or aluminum cover that snaps over your line set. And again, this really gives you both better looks as well as better protection of that line set. You'll see there's a pad on the bottom of this one. They made sure they compacted the ground first. So getting compact ground so this won't settle or tilt, then putting the pad on it is a great first start. Next, you want to use some adhesive to adhere any riser blocks and then anchor the foot to that riser. Again, there are various types of risers available. 2 or 3 inch risers are kind of standard. We prefer 6 whenever possible. That just gives you that little bit of extra benefit for when there's a lot of leaves or a medium amount of snow. If you're in an area with high snow on an annual basis or typical snow drifts, you may want to consider wall mounting the outdoor compressor. These preferred risers, here's what I was mentioning. These are really nice looking, which is nice. It's something that once you get used to it, you can do it repeated over and over and over again. And we recommend that 6 inch as your standard, except for those snowbound areas where you may want to reconsider wall mounting. The outdoor unit, again, sits on a level surface. That's pretty critical to make sure these things will run correctly. We want to use these risers, as I mentioned before. Here's a different version of it on the top picture. And you definitely want to make sure that you're using both bolts and adhesive to secure this. We want to make sure that this system will not go anywhere. The condensate drain, I mentioned this earlier. It must slope away from the building. As you can see here, if you have it sloping towards the building, you have that potential for, creating little pockets of moisture that could attract rodents or creating building damage. And please do not terminate these into a crawl space or on a paved pathway. It's just problematic for a number of reasons, one of which could be even freezing risk from any condensate. Defrost discharge, another challenge. Defrost discharge, during defrost cycle, any frost that's built up on the outdoor coil will usually be defrosted either because the system goes through a special cycle where it reverses temporarily the temperature. So during cooling mode, it temporarily provides a little heat or reverse. It will defrost any frost that's on the coils, but it will also create some moisture that comes off it. So being smart about where you install your outdoor compressor and making sure your discharge drains appropriately is really a good idea. The lower picture is actually a pan heater that is really another specific element often used in defrost modes. These can be ordered with the equipment or they can be purchased separately. We only recommend them when you're installing cold climate ductless heat pumps in a colder climate. The reason why is they do use extra energy in order to work. We also want to make sure that the way they're controlled is to only come on during defrost cycles. Now that should be a standard for most pieces of equipment these days, but it's the kind of thing you're going to want to learn more about as you're going through manufacturer training, really understanding how the defrost mode works and what considerations need to be taken into account. Remember, during defrost, outdoor units can discharge actually a fair amount of water, and there really could be some freezing hazards with that. And make sure again that if you're installing the pan heater, it only is going to come on during defrost cycle. If you are installing west of the Cascade Mountains or in an earthquake or volcano area, you may actually be required to put specific earthquake straps on. If you look at this picture, near the top, you'll see a strap from the top of the compressor being mounted to the wall. And there are lots of codes and jurisdictions starting to require this, so you may really want to consider this a standard part of your installation process if you are installing ductless heat pumps west of the Cascades. Now let's talk about the indoor heads. Some critical things. We want to make sure that they're installed high in the wall, usually at least 7 feet off the ground, and this is so that you really get the best mixing in the room. You want to make sure that this unit is level. This will ensure that the fan runs properly and for the longest amount of time. And really think about, make sure there are no major walls or disruptions in the way of this ductless heat pump head, this indoor head. It should have minimum 8 to 20 feet of clearance in front of it, so it really gets best mixing for the room you're in. When installing this head, remember penetrations through the wall are necessary for the line set and the electrical. And we really want to make sure that both the drywall and the siding are well sealed. And if you're going to use spray foam around there, that's a great idea, but make sure it is well covered from both weather and UV. That spray foam, while it's a great product, if it's exposed to UV for long periods of time, it will start to change color and eventually degrade. These line set cover that you see being installed here are really nice, and they also come with corner pieces that actually cover that penetration. So this really is the most professional looking installation and will also give you the best results. Now let's talk a little bit about common mistakes that we see with ductless heat pump installations. There are some real common things. Again, I mentioned earlier, maybe the most common thing is not having proper expectations or homeowner education, but there are some other things we see. The outdoor unit not being secured or elevated in areas of snow and not being level are really common problems. And it's a good way to make sure that you fail a quality assurance site visit. So take care of that. It will improve the longevity of the equipment and make sure that it works correctly. The second big problem is lack of adequate line set protection. So what you see here, it is insulated, which is great, but this is not a UV proof insulation. So it either needs to be covered with a tape or some sort of sealant or hidden under a line set cover. That is really critical. Now, in this particular case, this is an outdoor unit, and you see there's a lot of different refrigerant lines. This is not your standard displacement, one indoor head, one outdoor head, and so that's probably why this installer did not use line set. He or she had too many refrigerant lines running simultaneously. So in this case, having a sealant, using the correct line set insulation, or putting a UV wrap over it would be preferred. Again, these other mistakes, that poor homeowner education that I mentioned, not having good clearance around the device, really having aesthetically unappealing installations, and in general, not installing the heads level on the interior. We see these on a pretty regular basis, and it's usually because people are moving quickly and trying to get that best price for the homeowner. But if you have to come back to fix the job, you didn't give them the best price. So here's going to go through some examples of some poorly installed outdoor units and then some poorly installed indoor units. So here, clearly they did not put a pad on compacted ground. You can actually see they put this on these concrete blocks and it's sinking into the earth. This is not a long-term good solution. It is also not earthquake strapped, and that insulation does not appear to be covered either. So this is really failing on several different levels. It may work for a while, but over time, this device is going to be a challenge to live up to its 10 to 20 year life. Here we have another one. It's installed outdoor, but you can see this is a picture taken in February, so there's some defrost happening, and the defrost is running right onto a walkway where people are likely to walk. And considering that this is happening in February, is a good chance that could freeze. It also does not appear to be very level. So again, you could risk the longevity of the equipment, and you could cause a slipping hazard here. Finally, it doesn't appear that the penetration through the wall has been adequately weather sealed. You can probably guess what's going wrong here. We see refrigerant lines. Now, it has the good insulation on it that has UV protection, but it's not covering all of the line set. If it doesn't cover that line set, you could either get condensation on it, and you're certainly going to get reduced performance. This needs to be insulated so that if you're taking heat from outdoors and moving it inside or moving cool inside, you want to make sure it's actually going to get the job done and not lose a lot of that heat along its journey. And we do that by making sure they're properly insulated. I kind of hinted at this earlier, but one of the tricks is to push back the insulation when you're making the connections and then let it kind of accordion back out to cover the entire line set. In this case, it was simply trimmed back too far to make it easier for the connections, but now we're going to have a poor performance over the long term. Now let's take a look at some poorly installed indoor units. Now this device may actually work well, and I'm very glad that they used a line set height on the inside, because where they had to come through was not directly behind the head. But they've left this ugly hole above the bottle on the right. It's not sealed and it's not covered. And they actually make elbows or turns for line set hide that would have done a terrific job to cover that. So this was a matter of just not having the appropriate piece of line set hide on hand. But that's an easy to fix problem. But let me ask you, if this homeowner was trying to show their neighbor your installation, what are the odds this will lead to a referral? Probably not very high. So making sure you have a professional looking install on top of a level install is going to be critical. Here we have a head that is neither high on the wall nor is it level. So this is really just not going to move the air as it's designed. If a homeowner doesn't have an option for a high on the wall head, they actually make what are called floor mounted units, which is a bit of a misnomer. It's actually mounted on the wall, but it's just at the level of the floor. And the difference is it pushes the air up into the room instead of down into the room. So it will work, and it will work very well, but we only really recommend those for this scenario where you can't put a head high on the wall. So this is a good example of probably the wrong piece of equipment was selected here, and it was not installed level. And that doesn't just happen once. It happens over and over again. Here we have another instance. It's neither level nor is it high on the wall. A floor-mounted unit would have been the right choice in this case. Okay, so in the last 40 minutes or so, we've gone through the basics. We've talked about the line sets. We've covered compressors and indoor heads. And then we talked about common mistakes. Now I want to talk a little bit more about resources for you, because again, all of this is just an introduction to get you started down this path. We want you to be thinking more about how can you continue to be educated, what's the next step, so let's take a look at these resources that are available to you. First is our website, goingductless.com. What we love about this website is there's actually two ways to view it. When you first go to goingductless.com, you'll land on the homeowner or consumer facing website. And this gives a lot of resources for consumers to help find contractors, find utility incentives, and actually download some of the information that will help them think about, is a ductless heat pump right for me? But you can also select to view this from the partner or trade ally or contractor view. And so in the upper corner, you can click on a little button and choose partner or contractor to get a suite of resources designed just for you. These are things to help you with sales, things to help you with the homeowner education, best practices. All of this are going to be located there. And so we highly encourage you to kind of bookmark this on your web browser as your first resource you're going to use. Next, we have this HVAC technology guide. This is from the people at Bonneville Power Administration, and it's not specific to ductless heat pumps. It covers a lot in the HVAC arena, but it's actually a really detailed and really good guide, and terrific for those of you truly new to HVAC. If you're already an HVAC contractor and you're new to ductless heat pumps, you may still find some good things here, and it may actually help you think through this idea of mini splits, one outdoor head, one indoor head, one outdoor compressor, multiple indoor heads, or multiple one-to-one systems. A lot of that's going to be covered in this technology guide. More specifically, this technology overview would cover the HVAC basics, which is always going to be critical, and I think actually everyone on your staff should understand these HVAC basics. The terminology and fundamental concepts are critical. So whether it's the person answering the phone, who's setting up appointments, your sales staff, or even the people creating the invoices, being able to understand the terminology and understand those fundamental concepts will help everyone along speak the same language and help everyone make sure that jobs are being done correctly. The HVAC technologies will go into specific details on a lot of the different technologies we're talking about and which ones are most relevant to the Pacific Northwest. That does actually make a difference. And finally, there's cross-cutting topics such as how does these basics and these guides and these recommended practices we're talking about, how do those align with building codes and federal efficiency standards? So again, there's a lot in here. Yes, it's a fair amount to take on, but if you're going to be successful with installing ductless heat pumps, really understanding the technology is going to be critical. Next, getting your real installer training. So again, what we've gone through today and what we have through our learning management portal are wonderful overviews and wonderful orientations to the world of ductless heat pumps and to our program. But you really do need to get this hands-on training. So you can talk to your distributors and manufacturers. By the way, these are just some of them, not all of them, and these are just put here alphabetically. There's no preference given to anyone here. But there's a lot that's out there and a lot that's available. And we find that really building a quality relationship with a manufacturer and a distributor is going to be your best long-term solution. Because when you do have a challenge, and you will, who do you know how to call? Who will actually respond and give information that is specific to the equipment you're installing? Your distributor and your manufacturer. The good news is, on our goingductless.com website, you can click on training and events through the contractor portal, and you'll actually find where local training centers are and lists of events and classes that are happening on a regular basis. And here we go. Find a training center. The training and events and training centers are easy to navigate. You can type in your zip code and find where the closest trainings are and when they're happening. You can get them specific to your manufacturer as well by following this system. So we've covered in the introduction to DHPs the business case to start, and then we talked about sales. We also talked about design considerations, and we've just finished with installation recommended practices. Again, the goal here today was just to give you a big picture overview. You really are going to want to go through a few more steps. If you want to be working with the Northwest Ductless Heat Pump Project and actually providing incentives to your customers, you're also going to need to go through our DHP program orientation. And you do that through our learning management system, and that allows us to collect information, to post your contact information on our website so consumers can find you. But it also will give you more details about how our program works, what the minimum requirements are for the equipment to install, and the general process that most of our utility stakeholders are following for providing incentives. There's also a master installer designation for those of you that really want to really master this work, and that's for contractors that have installed at least 25 ductless heat pumps, with a large portion of them being utility incentivized. There's additional training for that. You can go through that as well through our learning management system. One word I would give, different utilities have different requirements for minimums in order for you to participate in their incentive program. Almost all of them in the Northwest will require the DHP project program orientation as a baseline. Some of them will also require the recommended practices, and some of them will also require manufacturer training, which, as we've hopefully established by now, is going to be critical for you to really grab a hold of this and make this a key part of your business. Feedback. We love feedback, whether it's feedback on this series of modules or it's feedback on our program in general or on our website. Go ahead and email us at info@goingductless.com, or even if you have follow-up questions, and we're happy to answer your information. Just know that if you do email us, make sure we have the best way to get a hold of you in your email so we can follow up. We're always looking for a few new contractors who are interested in learning more and who are interested in kind of sharing their experience about becoming a ductless heat pump contractor with our program. If that sounds like you and you'd like to learn more and you'd like to work a little bit closer with us, we can give you some additional support in exchange for learning how your business has adopted this. We find that to be a good mutual benefit, and we hope that you will too. So with that, I want to thank you so much for spending the last 40 to 45 minutes on this module. Again, if you did not see the other modules and you're interested, the business case, the sales, and the design considerations are all also available through the same YouTube channel that you found this. And we hope that you'll watch all four. And in a best case scenario, we hope you'll also become an oriented installer in our program. Thank you very much. We really appreciate your time.